To improve the logistics business sector using AI, what internal, within organization, and outside organization data is required? Pradeep K. Suri. Author and researcher. Internal data for AI in logistics. Internal data provides a foundation for AI to understand the current state of your logistics operations and identify areas for improvement. Some crucial internal data sources include 1. Inventory management. Stock keeping units, SKUs, product information, including descriptions, dimensions, weights, and locations. Inventory levels, current stock levels for each SKU across different warehouses and locations. Demand forecasting, historical data and predictions of future demand for each SKU, house stock keeping units. Safety stock levels, minimum stock levels maintained to avoid stockouts. Lead times, time taken to receive new inventory from suppliers. 2. Transportation management. Transportation routes, geographic data and routes used for shipping goods. Transportation modes, data on different transportation modes used, air, sea, road, and their costs and delivery times. Vehicle data, information on vehicle types, capacities, fuel consumption, and maintenance schedules. Driver data, hours of service, driver availability, and performance data. Shipment details, information on each shipment, including origin, destination, weight, and dimensions. 3. Warehouse management. Warehouse layout, physical layout of the warehouse, including storage locations and pick paths. Inventory movements, data on all inventory movements within the warehouse, including receiving, picking, and packing. Labor data, information on warehouse employees, their roles, and work schedules. Warehouse performance metrics, data on key metrics such as picking accuracy, order fulfillment time, and warehouse utilization. 4. Customer data. Customer information, contact details, order history, and preferences. Order data, information on orders placed, including items, quantities, and delivery schedules. Customer feedback, feedback and reviews from customers about their experience with the logistics service. 5. Financial data. Transportation costs, costs associated with different transportation modes and routes. Warehouse costs, costs associated with warehouse operations, including rent, utilities, and labor. Inventory carrying costs, costs associated with holding inventory, such as storage and financing. 6. Operational data. Sensor data, data from sensors in warehouses and vehicles, such as temperature, humidity, and location. IoT data, data from IoT devices used to track goods and assets. Machine data, data generated by machines and equipment used in warehouse operations. 7. Network data. Logistics network data, information about your transportation network, including routes, carriers, and partners. Global trade data, data on trade flows between countries and regions. Weather data, information about weather conditions that could affect transportation and delivery. 8. Regulatory data. Compliance requirements, information about relevant regulations and compliance requirements. Trade agreements, data on trade agreements between countries that affect logistics operations. External data for AI in logistics. External data can provide valuable insights about the broader market, economic trends, and customer needs. Some key external data sources include market data, information about market trends, competitor activity, and customer demand. Economic data, data on economic indicators that could affect logistics operations, such as fuel prices and exchange rates. Transportation data, data from transportation providers and government agencies about traffic conditions, port congestion, and weather delays. Supply chain data, data from suppliers and partners about their production schedules and inventory levels. Social media data, data from social media platforms to understand customer sentiment and identify emerging trends. News data, information about current events and disruptions that could impact logistics operations. Public data, government data sets on demographics, infrastructure, and environmental factors. By combining internal and external data, AI can gain a comprehensive understanding of the logistics landscape and identify opportunities for optimization. This can lead to significant improvements in efficiency, cost savings, and customer satisfaction. Additionally, AI can be used to optimize transportation routes and schedules. AI can analyze data on traffic conditions, fuel prices, and weather patterns to recommend the most efficient routes for deliveries. Predict demand and optimize inventory levels. AI can analyze historical data and customer preferences to forecast future demand and ensure that the right products are in the right place at the right time. Automate warehouse operations. AI-powered robots can automate tasks such as picking and packing, improving accuracy and productivity. Prevent and detect fraud. AI can be used to analyze data patterns and identify suspicious activity, helping to prevent fraud and theft. Improve customer service. AI-powered chatbots can answer customer questions and provide support 24/7. Reduce carbon footprint. AI can be used to optimize transportation routes and reduce fuel consumption, helping to reduce the environmental impact of logistics operations. Based on the internal and external data mentioned, here are some potential AI forecasts for the logistics sector. Demand forecasting. Product-specific demand forecasts. AI can predict future demand for specific products, allowing companies to optimize inventory levels and production schedules. Seasonal demand fluctuations. AI can account for seasonal trends and predict periods of high and low demand, ensuring efficient resource allocation. Customer behavior and demand trends. AI can analyze customer data to identify purchasing patterns and predict future demand based on individual customer preferences. Transportation optimization. Dynamic route planning. AI can analyze real-time traffic data and suggest the most efficient routes for deliveries, minimizing delivery times and fuel consumption. Multimodal transportation planning. AI can combine different transportation modes, example air, sea, road, to find the most cost-effective and time-efficient way to move goods. Predictive maintenance. AI can analyze sensor data from vehicles to predict potential maintenance issues, preventing breakdowns and ensuring smooth delivery operations. Inventory management. Optimizing inventory levels. AI can predict demand and recommend optimal inventory levels for each product, reducing the risk of stockouts and overstocking. Dynamic warehouse layout optimization. AI can analyze warehouse data and suggest layout changes to improve picking efficiency and reduce warehouse operating costs. Predictive expiration date management. AI can analyze product data and predict expiration dates, allowing companies to sell products before they expire and minimize waste. Customer service. AI-powered chatbots. Chatbots can answer customer questions 24/7, provide order updates, and resolve basic inquiries, improving customer satisfaction and reducing contact center costs. Personalized recommendations. AI can analyze customer data and recommend relevant products and services, increasing customer engagement and sales. Sentiment analysis of customer feedback. AI can analyze customer feedback to identify areas for improvement and ensure customer satisfaction. Logistics network optimization. Identifying potential disruptions. AI can analyze data from various sources to identify potential disruptions in the supply chain, such as weather events or port congestion. Optimizing supplier networks. AI can analyze data from suppliers and partners to identify the most efficient and reliable suppliers. Predicting global trade flows. AI can analyze trade data and predict future trade flows between countries, helping companies make informed decisions about their global operations. Carbon reduction. Optimizing routes for fuel efficiency. AI can analyze data on fuel consumption and suggest routes that minimize fuel usage and carbon emissions. Shifting to green transportation modes. AI can help companies identify opportunities to use more sustainable transportation modes, such as electric vehicles or rail. Creating eco-friendly warehouses. AI can analyze data from warehouses and suggest ways to reduce energy consumption and waste production. These are just a few examples of the potential AI forecasts for the logistics sector. As AI technology continues to develop, we can expect to see even more innovative applications in the future. It's important to note that the specific AI forecasts will vary depending on the individual company and its specific needs and goals. However, by leveraging the power of AI, logistics companies can gain valuable insights and make data-driven decisions that improve efficiency, reduce costs, and enhance customer satisfaction. Thank you.